a second. I got to free up some space on my hard drive. Let me do that real quick so I can make sure we don't have any issues. I'll delete.
Let's see, do you want me to provide some HADR by doing a recording on my side for you?
No, yeah, that'd be great. Let's both record it. Would you mind?
No problem.
I've never tried that. That'd be great. So let me see if I got some more spots. User space. You do? Okay. Kenny's going to record it. Great.
Yeah, anyone that's an organizer should be able to.
Okay. I'd like to welcome everybody to the Data Architecture chapter. My name is Rob Canzaneri, and I'm the virtual chapter leader. And today, I asked John to come on and give a session on table partitioning. Thank you, John, for coming today.
No problem.
So we have a sponsor, it's Nutanix, and we would like to thank our sponsor for giving us the opportunity to talk and have these webinars. And they make it all possible with their sponsorship to PASS. So future meetings, I have Brian on here. He's going to talk about R integration. Kimberly's going to come on and talk about database design. And Tim, I asked Tim to come on here and talk about SQL Server performance, tuning advice, how to get started with that. So PASS is going to have the Civic Technology Movement webinar coming up, and it's hosted by Excel BI chapter and the PASS Business Analytics chapter. So I would recommend logging in to the PASS website if you're interested, and just click on those links and you can sign up for their webinars. Another thing that's going on is there's the Business Analytics Day, and if you want to find out more, there's the website http://baday.com. Click on that, and you'll find a little bit more about that coming up. So one cool thing about PASS, I talk about it a lot, is there's a lot of virtual chapters, and here's kind of the list of the virtual chapters. So if you're ever interested in other topics other than data architecture, maybe HA, sign in, and every month or so. I mean, they're always having these great webinars with great topics, and check it out. And that's my end, so I'm gonna go change it over to John. Okay, John, it should be good.
All right, let me know if you're able to see my screen.
I can see it.
Sweet. All right, we'll get started. Well, Rob, thank you for the great introduction. As we kind of talked about a little bit while we were warming up and waiting for people to pop in, I am the founder and leader of the HADR virtual chapter. So I always look forward to seeing people pop over there. And if anyone is interested in speaking over there, we're always looking for new speakers, especially people that want to get into speaking. So you can get a hold of me through my Twitter. My email is just john@procureSQL.com or anything like that. A little bit about me. I'm an MVP. I've written a book with Tim Radney, who'll be speaking shortly in a couple of months here as well. And I'm certified and all that fun stuff. I'm the founder of a small consulting company called Procure SQL, and I do a lot with performance tuning, high availability, and basically anything you can do inside of a relational database. And today we're going to be talking about table partitioning because it's something that I've had a lot of experience using in a lot of different environments, from data warehousing even to some OLTP environments as well. So today we're going to focus on basically what you should really want to know and a lot of the mistakes I've made along the way of learning how to do table partitioning through the many years. So I've started table partitioning all the way back to 2005 when it came out, and have been using it in a lot of unique, interesting ways. So in fact, just finished a great project where I've used it with column store as well to make a table that was over 500 gigs go down to 1 gig and make queries go from hours to seconds. So I look forward in the future to maybe doing some column store stuff here as well. But today we're going to focus on table partitioning. And so here's basically what I'm going to try to cover with you in the next, we'll say, 50 minutes or so here. And we're going to go through a lot of the core basics that developers, DBAs, architects all need to know. And this is basically to learn how partition can help you manage big sets of data. So I've done table partitioning with data all the way from, I would say, 20 gigs to 80 terabytes, anywhere in between there. So the more data you have, if you use it strategically the best way, some of the better savings you're going to see across the board of performance maintenance and managing the data. But we're going to go over some of that stuff. We're going to go over how you can basically just learn how partitioning works. So if no one's ever used this before, this might be a good session for you to kind of understand behind the scenes how things work and how you can kind of control it to make it work for you and your data as well. And then at the very end, sliding windows could be their own multi-hour sessions. We're just going to go over a basic sliding window to show you how you can actually archive and purge data and get data in and out as well. So some assumptions here. One, table partitioning is an Enterprise Edition feature. So you need to have Enterprise Edition or Developer. And 2016, you can now get Developer for free. So if someone wants to learn this, now anyone can do it without spending any money. And like I said, you have to have a good amount of data. If your database fits on a thumb drive, you're probably not going to see much results out of table partitioning. But we'll talk a little bit about doing this on-prem, and I'll even give you some tidbits for doing it out in the cloud as well if you're going to do like Azure SQL database as a service. We'll go over some general maintenance tasks and dangers for not meeting your SLAs and how you can get back in line. This is actually the first way of how I got into table partitioning, as we had tight SLAs and we were at the point where we weren't going to be able to meet them anymore. And then we'll talk how you can do pretty instant purging and archiving of data to your app regardless of the size of data that needs to move out in a partition. So the big question, right? Table partitioning is completely useless unless it makes your life easier. So a couple ways on how table partitioning can easily help you out, which I talked about a little bit already, is your general maintenance tasks. So these are things that we'll talk about, like, for example, your backups that you're doing, your index maintenance, your stats maintenance, all those kind of things. We'll go over how you can actually start to do those based on a partition instead of the whole entire big massive table as one unit. We'll talk about purging and archiving. So if you usually have a big set of data, a lot of times you're going to have one process that may purge the data or archive it out to another system like a data warehouse or some other database for reporting or some other purpose. So we're going to talk about how you can really help that process as well. And then finally we're going to talk about performance. And these are the key drivers. So whenever you're thinking about table partitioning, you kind of want to think about these three items and kind of figure out which one's the most important to you, because it will be key towards building your table partitioning strategy for your table or tables. So I list performance last because it's where people want to start, and it's an area where if you don't fully really understand partitioning, you could really shoot yourself in the foot. But we'll go over some good lessons there as well. So the very first question, okay, now we kind of know three key areas where partitioning can be helpful to us and make our lives a lot easier. How does this thing work? So very high level, every single database is partitioned. Even if you are in standard edition, you don't have support for table partitioning, it is partitioned, you just only have one single partition. So very high level, we'll say we have big table, right? Your normal way without partitioning right now, you're going to have a file group, and then that file group can be split out to one or multiple data files. So kind of the same concept here with partitioning, except we're breaking up those units or buckets of partitions, where each individual partition can have its own file group. It doesn't have to. So for example, I mentioned a little bit about Azure SQL databases. There you would just use primary all because you have no control to the actual file groups and the database files used for them. But here on-prem as an example, or in a VM out in the cloud here, you can specify file groups here and then have different data disks for them. So for example, if you know the very last week's worth of data and maybe a reporting environment, it's very crucial and going to be used a lot. You can have that on top tier storage as an example, compared to some of the older stuff that you just have to keep for historical purposes can be on slower disks. And by having different file groups, different data files is basically how you can get there. So now we know the storage and how that works. Here's kind of the very high level. And the way how you implement this is going to be backwards. When I say backwards, we're going to talk about this from top left to bottom right, but implementation, as you'll see when we get to it, is going to be from bottom right all the way up. So the first thing what we're going to want to do is we're going to figure out, okay, which table needs to be partitioned. Once we've made that determination, we're going to have to figure out what column are we going to partition off, because you only get one single column to pick. So from there, basically, you would end up figuring out, okay, we're going to use a scheme. The scheme is what's going to physically break up the file groups like we see here, where we kind of see on the right there, there's partition 1. It has its own file group, and it has its data files. The partition scheme is what's going to bound each partition there to the actual file groups, which will then connect to your data files. The partition function, so this is our driver. Once we pick our column, our table, we'll say, for example, sales, fact sales, as an example. And in there's a date column that we're going to want to break our partitions off of. And then we'd build our partition function. We would specify the data type, which would be date time or date as an example. And then we'll specify our boundary points that set up those partitions. And then from there, the scheme will bound those to file groups. And we'll go through an example showing you exactly how that all ties in from scratch. So as we start out here, key big mistake a lot of people may make is not selecting the right partition column. So as I mentioned, you only get one single one, so you want to use this very wisely. And this is what's going to split up our partitions here. So there's a couple ways on how you can select which one you'd want to use, especially if you're doing this for performance. So a couple things you could do is go off and look at your index stats usage if you don't know how the table is currently being used. In fact, I had a case recently where I did some partitioning where that became very helpful, as the end users and the business owners were definitely unsure. You can also look at missing index statistics, and the key thing too is talk to everyone that's involved with the system and actually see exactly how the system is going to change. So I had a case a couple of years ago where we went through the first two steps, and then we're talking with some key people. We found out how the table is going to be used was completely different in 6 months. So to prevent us from doing all this all over again, we were able just to do it the right way for the long-term benefit. And of course, this column is going to end up being part of the clustered index as well. So that's another key thing to note. So our partitioning function, so once we've determined, okay, what column we are going to use, your next part here is you're going to build out a partition function. And as I mentioned, your key things that you're going to do here is you have to determine what data type are you going to use to split up your data into partitions or buckets, as I like to refer to them. Then you're going to have to say what kind of range do you want your boundary values to be, what do you want them to do. So you have two options. Range left, which is the default, so if you don't specify anything, it'll be a range left. Or you have range right. So in this example here, we have 3 boundary points, 100, 200, and 300. So we'd actually have 4 partitions, because you're always going to have one more partitioned in boundary points here. And because we're specifying range left, this means that those boundary values will go in the left partition. So for example, for 100 being our first value, that means null and anything less than and including 100 would be in the first partition, because we're doing range left, and 100 then would be the last value in the left partition, which would be partition 1. Same thing for 200. So 101 to 200 would be partition 2. Now, if we were to flip this around and say range right, it would be the opposite, to where 100 would then be the very first value in partition 2. So yeah, keep in mind that your null values are always going to go in the leftmost bucket, so your partition 1. And then of course, most likely, these partitions are not going to be static. So just like an index that you would create, you kind of have your starting point, which we would go through and set up. But then over time, we're going to want to probably add new partitions and maybe remove old ones to do archiving and purging as well. And so that's going to happen with split and merge statements, which we're going to get to here in a bit. But the key thing to note is now that you see how we're setting up these boundary points to set up partitions, they're not going to be static. Most likely you're going to have them change over time as you're doing your sliding window. So here's an example, and we'll go through this on a demo too, but this is just kind of making sure everyone understands the key basics here. So range here, so you can see for range left, as I mentioned, which is the top one here, we're using int, and we have our 3 boundary values, 100, 200, 300. So we have our 4 partitions here, and the boundary points, which are the numbers in the parentheses, 100, 200, and 300, are going to set up the boundary points for the partitions. So the first one, it's range left, so as I mentioned before here, null, because it's partition 1, and anything less than and including 100 will be in partition 1. So anything that's greater, in this case since we're using an int, the next value would be 101, including 200 will be in partition 2. When we look at range right here, we're going to see this change a bit. And this is really going to come out to us when we're using dates, which I'm going to show in our first demo here in a second. But the only thing that's changed on the bottom one is we're doing range right instead of range left. And so what this means now is null, and anything less than or equal to 99 will be in partition 1. And so the reason why 100, which is our first boundary value, is in partition 2 is because we're doing range right. So right means the boundary value goes in the right partition. And that's the big change there. So now our boundary value will be the first value in the partition on the right. So 100 is the first value for partition 2, 200 is the first value for partition 3. It's a key concept to understand. Because once we've set up our partition function to know where our data is going to go, then we can map this out to actually file groups. And that's what the partition scheme does. It actually will then say, okay, here's our function that we just created. Now we want each one of those partitions to be mapped to particular file groups. And remember, file groups, that's then how you can specify data files to be used. So in this case here, we're having a separate file group for every single partition, but you could also do partition primary all as an example, and that way it would just use the primary file group. And with that, we'll go ahead and we'll hop over here to our demo here, our very first one, where we're going to go over the key concepts and some functions that you can use to help you understand them as well. So I'm going to go ahead and use our AdventureWorks here. And the very first thing we're going to do is we're just going to walk through and look at what would happen with data values based on our function. So same thing here, we're going to go ahead and create one. I'm doing the default here, so you don't see range left or range right, but range left will be your default if you don't specify. So I'm going to go ahead and we're going to create this. And the key thing to show you is any data, so we haven't mapped this to a table yet, but we can run a function, which I'm going to show you, that will let us know exactly where data would go if we had it connected. So here, as we said before, we're doing range left, so each boundary value will be the last value inside of a partition, as we can see here. So the nice thing here is there is a function, $partition, then you can do dot and your partition function. And if you pass in a value here, it'll tell you exactly which partition the data would go into. So so we can see this here, let me go ahead and scroll up. So as we can see, null will go into partition 1 because we're doing range left. -1 is less than 100, so that will also be partition 1. And because this is range left, 100 will be the very last value in partition 1. So we should see a 111 2, because 101 will be the first value in the second partition. And then this very big number that's well over 300, it'll go off into partition number 4. So when we run this query, That is exactly what we're seeing here. So 1, 1, 1, 2, and 4. So let's go ahead and take a look over here. And now we're going to do the opposite with range right. So once again, the thing that changes now is our boundary value goes to the right. So instead of 100 being the last value in partition 1, it's now going to be the first one in partition 2. So we rerun the same query. We'll get the exact same results, except the third value here, 100, will now be in partition 2 instead of partition 1. All right, so now let's play with dates, because when you're working with dates, this is where I see a lot of people make some basic mistakes that causes data to be in two different partitions when you're running queries, when there's only one single value that you're looking for in a partition. And when you're doing this for performance, this can cause you to scan two partitions by mistake by just not implementing and understanding the boundary values the correct way. So I'm going to go ahead and drop that same function, and now we're going to work with dates as an example. And we're doing range right, so that value will be the very first value in the partition on the right, which is very good for dates, which I'm going to show you here. So here we have, for example, the 7th, so that's July 2012, that's our first one, and then we're doing one every month after that. So what I'm going to do is I'm going to throw in the lowest value and the highest date value that you can have with date time in here for that date. And because we're doing range right here, we're going to see these are going to stay in the same partition as one would expect. But the key thing here is if we did range left with dates, we're going to see something a little different here. We're going to actually see, because range left means that that boundary value will be the last value in the partition on the left. We're now going to see a use case here where we're going to have the very first value of that day be in partition 1, but every other value for that day would be in another partition. So if we were wanting to do a query and filter off our column here, we would have to go across two partitions, even though we only have one single record that would be in that partition 1 for that date. So another thing to go over here quickly is just how fractions work with date time, because this can also throw people off, which is why I like range right with dates. Here I'm just taking the last three possible values and we're converting that over to date, and you'll see that they actually get rounded as well. So 997 stays 997, 998 becomes 997, and then 999 gets rounded up to the next day. So once again, if I was going to say range left, and this is another mistake that I've seen, is if you want to go off what you think is that last date value, remember the 999 will actually get pushed out to the next date. So you can have that partition boundary mistake on both sides of a date. All right, so, and then one more thing that I wanted to show here is how does this work with an actual table now? So we kind of went over scheme and function, but let's go ahead and let's implement this on a table. So I'm going to go over here and I'm going to add those file groups here. And then I'm going to go ahead and just assign some data files to them. And then now we're just going to take a quick peek at the data that we have for this table. So remember, one of the big steps here is to kind of see how the data is organized. And we see we've got a pretty good distribution, which is kind of your goal for partitioning. You want to try to have an even distribution of data because our end goal here for performance is to try to skip partitions. And if you have all of your data in one partition and you have a bunch of other ones that don't have data, if you're skipping the ones without data, you're not really going to be benefiting that much. So now we're going to actually go through and we're going to create a partition scheme and function that we're going to actually end up using here for that table there. So here I am creating our function. I'm using date time, and my first data value is going to be our first date value, so only nulls would go in the far left partition 1. And then from there, we're just doing yearly partitions starting with 2007 up to 2012 here. And then now here, I'm going to actually assign the file groups here to those boundaries or partitions as we created the file groups that then had data files attached to them. Once again, if you're like an Azure SQL database, you don't have control, you can't create file groups, but you can tell it to do it to primary all. And so now we're going to take a quick look at our scheme here and how things will be broken in. So we haven't put data in yet, but this is kind of tying the scheme and function together for you. So we're doing a range right, so file group 1 would be null and any value up to 1901, which would be our first date time there. And then from there we're going off of yearly partitions. So how do we make this partitioned? You kind of have two main options here. If you're in like a data warehousing environment or some batching environment where you actually have predictability about how the data is changing, one area that might be a good way for you to do is build the table out, put data in there that's not going to change over time, and then as you go live only change the data that needs to change in new data. Or you can drop and recreate your clustered index. So here's an example here where we're going through, and I'm basically going to rebuild the clustered index. The key difference that we're going to see why this is happening here is instead of specifying a file group, so normally on a regular table, right, you'd say on primary or you'd give it a file group name. Here, the way how we actually make the table use the schema in the function is we say use the schema for instead of the file group, and then we're going to use a column that has the same data type that we specified in our function. So that's how those tie in together, and that's how you would make the table be partitioned in here. So here's a very big query that I will include so you guys can get if you want. But this kind of gives me my who, what, when, where, and why about table partitioning. So pretty much the same as the last query, except now I have exactly how many rows are in the buckets there, or partitions. And so one of the things as a strategy for doing archiving and purging, where we're going to start to do a sliding window, you're really going to want to have no rows in your first bucket here or partition, and 0 rows in your last one. So keep that in mind as we go through our sliding window. That'll make sense there. But we always want to have zeros in there because it's a lot easier to move partitions that have no data than data that's in them. But that's basically how we'd make a table be partitioned and have all the data go into the buckets that we specify based on the column and also the boundary values like we've done here. All right, so now that we've kind of gone over the basics there, the next thing we're going to want to tackle is maintenance. So as I mentioned, this is how I first got into table partitioning way back in 2005. We had a table that was a couple terabytes, and as it grew to that space after some business processes changed, we were starting to not meet our daily limit or our limit that we had for completing these maintenance tasks. So ways how we can improve some of these is by doing what we need by partition. So for example, in 2016 we've added truncate table by partition. So if you are just purging data, you could simply just truncate that one partition. And then 2014, you have rebuilding indexes online by partition. So in 2005 up to 2012, you can still rebuild an index by partition. It's just an offline operation instead of online. So we also have the manage lock priority, so we can kind of say who becomes the boss. And you also have incremental stats there as well. But the main driver here is that this is really going to help you with managing your data by partitions. So we're going to go ahead and jump over to our next demo here that kind of shows you exactly how that will work. So let me go up here, up to the top. All right, so the very first thing I'm going to do here is I'm going to show you a classic example on how data can become fragmented pretty easily, even with one single query here. And I'm going to create a new index to show that. So we have a new non-clustered index here on my partition table. So we're going to see where I have PT. That means that the table is the partition. I'm going to have another copy that's the exact same except it's not partitioned. And we're going to make the index aligned. So what that means is our index is aligned because instead of specifying a file group, it's going to use our same schema, our same function that is used for the table and how the table is persisted. So that's going to be a requirement for doing the metadata switches, which we're going to talk about in a second, which helps you with your sliding windows. So all indexes you're going to want them to be aligned here so that you can do that. So now that I have this index, I'm going to run a basic query here that shows you fragmentation. Since we just created it, obviously we have very little fragmentation. And then what I'm going to do is I'm going to run one single query here, just one query. And I'm going to say, get us a new GUID, which is going to be random, for all of the data I have in the 2011 partition here. So one single query here, it affects 9,000 rows. And what we're going to see in here now is our partition number 7 has over 60% fragmentation from the one query. So what can happen in a scenario like this, which is exactly how I got into table partitioning, is if you look at the fragmentation for the whole table, it may just be right over your tipping point to do a rebuild. So for example, maybe the whole table of this is like 31%, my limit is 30. Because of that, you would have to do maintenance if you rebuilt that index across the whole entire table, which could be very costly and very long. So with table partitioning, I can actually go and say, you know what, only this partition needs it. Let's rebuild that single partition and let the rest be the way they are. And that's exactly what we'll end up doing here. So instead of going across everything, here we'll just go ahead and do our partition number 7 and only do the one that actually needs it, as we could see from over here. So the one gotcha here is, remember, before 2014 this is going to be an offline operation. But with 2014 and 16 we can now do this online. It's one of the things that I was really wanting ever since I started with 2005 there. So now that we've done that, we'll go ahead and look at our fragmentation here. And now we'll see we're back to our starting point there. So we only had to do maintenance across one single partition. So saving time and kind of controlling our SLAs here allows us to only do the maintenance across the partitions that need it. So pretty sweet stuff there. So another thing that we could talk about here, and this will go into performance a little bit, our next segment, is now that you have your own partitions here, as you're rebuilding your indexes, you can actually specify what kind of compression you would want per partition. So for example, this could be real handy in cases where you're maybe working with a data warehouse and the new data that's going to be used most of the time is just the data that's coming in from your monthly or weekly imports. We can tell each partition once it falls off and it's not the most important one, we can change the compression off of it, or just specify compression based off of the date of usage as well. So in here I'm just going to show you an example here. So this could be a whole long talk about data compression. And of course, that's even outside of column store, which is even another type of compression. I just want to show you here that basically you can control and specify what type of compression is then used per partition. So the whole objective for you to learn here today is just on a partition level, you can control exactly what type of compression is used per partition. Great. So with that, did we have any quick questions that popped in over? Because if someone had some questions on the very basics of this, I'd want to maybe answer one or two of those before we dive into performance.
Yeah, hey John, we do have a few questions. So let me kind of quickly scour over them and tell you what I'm seeing. I know one of the questions was, will you provide the handouts or, have a link to maybe...
Oh, yes. Yeah, everything is online. So I'm an attendee just like a presenter. So I don't like to write things, and I should have mentioned this at the beginning, but everything, the actual database, the sample scripts, the PowerPoint, they're all on my blog, and the last slide will have that link. Okay,
great. Here's one. Does table partition matter in the database in the cloud? So I'm guessing they're asking about performance.
Oh, definitely. It can help you there as well, whether you're doing platform as a service or Azure SQL database, or if you're doing through a VM. So yes, definitely. In fact, I have a client I just work with where there's 500 gig table. We got queries down from hours to seconds, and we had really good compression off that too. So yeah, yes, it definitely does.
The next question was kind of what I think you showed, but just to recap it, they are asking about backing up and restoring a partition table.
So your backups and your restores, if you decide to do it based off of file groups, if you have really tight SLAs for sets of data, then you can do your piecemeal file group restores to bring the data that's critical online. So yeah, in that scenario, you'd want to have as little as possible in your primary because you'd have to restore that first. But then from there, you could go ahead and restore based on your file groups there.
Okay. Here's the question. In the first demo, did you take the whole table from the original file into new file groups?
Yes. Yeah, we did. So let me to kind of make sure because I want to drive that home to make sure, because things make it a little sketchy here if people aren't understanding the basics of that. So yeah, at the very beginning here, we created a new file groups for each partition that we're using, which then we here have just different files per the file groups. And then down here, after we created our schemas, this here is how we implemented and we moved the data over to the new partitions. So the rebuilding your clustered index here, specifying the schema and the function here. So the schema is what we're using, and then we're using a column that's the same column as the function. That's what physically moves everything into those file groups, which we see below here. So here when we're looking at those row counts, these are the rows that are physically in those file groups that we just created. So yes, and that's how we went through and we did that.
Here's the last question. Oh, they're saying thank you.
Okay.
Is it quicker, which is quicker, one file or many file groups?
It depends. It depends on the usage and what you're wanting to do. If someone would email me that has that question, I'd be more than happy to spend like 15 minutes or so talking through your scenario, because it's kind of going to be unique based on how you're using the data.
Hey, John, I'll forward you all the questions, and
okay.
You can at least, you'll be able to see that question, the person who sent it.
Perfect. Awesome.
And they have a question about, one more question, really quick, is about your blog. Will you share your blog? I'm sure you will at the end, right?
Oh, yes, definitely, yeah. And it's just my name, johnsterrett.com. And we'll have a link to it, which we'll put here at the end. But yeah, if you can, Rob, just throw that in the chat for everyone so they have it. But
will do. Yeah.
johnsterrett.com. So let's talk about performance, because I know there's quite a bit of people that love performance and they want to figure out how to make everything run faster, just like me. But there's a couple of gotchas with partitioning if your main driver is to make performance better. And so here is a slide that's going to go over properties that we're going to end up seeing, and I'm going to go through in a demo here in a second. Our main goal is what's known as partition elimination. So not to be kind of confused if you use column store with segments and segment elimination, they're kind of similar. But with table partitioning in here, our main objective is to try to eliminate as many partitions as possible. So here's kind of an example of a best case scenario. We're going to have to scan across a table. But if we're using our filter, which was that column we used on our inside of the building the table to be partitioned, we can then skip partitions that aren't needed. So you don't change anything with your query. You could do select star from table where date, since we order date is our example here, where order date is in 2012. So automatically behind the scenes, the optimizer is going to say, this table is partitioned. And so if you go over the tooltip, that's where you would see partition and actual partition count. So that's the optimizer saying, oh cool, this table is partitioned, and we only need one single partition, so let's skip the rest of them. So that's what you'll see there. Now, if you go over to the properties, and I'll show this in a demo for an example, the wording here is a little misleading to me, and I think a lot of people when they start with table partitioning. So we see actual partition count equals 1, but it says actual partitions access 6. So most people when they see that, they think, oh my gosh, six partitions were accessed, but that's not true. That's the number of the partition or partitions that were accessed. So that's one thing to keep in mind. And then down here at the bottom, it's just results of running the exact same query across a table that's partitioned and that's not. And you're seeing the best case here is we're only going to scan once, and it's only going to scan the rows in that partition. Where the opposite case here, where you'd basically scan across the whole entire table. So that's kind of an example of our best case scenario from performance with table partitioning. Here's an example showing you with a scan how seeks work. So seeks that pop in here, there's actually going to be a seek predicate that gets added here. So this is actually going to be partitioning working for you. And same thing, this is all behind the scenes, the optimizer is doing it for you. It's basically doing a seek off of the keys there to figure out which partitions are needed. Then it's going to go ahead and use your columns that are in your filtering. And so here's just another example here showing you kind of a worst case scenario of, yeah, partitioning's being used, but we got to access all 7 partitions. And then on the tooltip here, you're seeing the 7 count, and the 1.7 means partition 1 through 7 are being used. So, and we already went over in a demo about compression and how you can do compression differently based off of each partition there. So quickly going over here, we're going to jump into partition performance. I'm going to scroll up here. So just real quick for baselining here to make sure we have the same consistent starting point. This is a demo box, not production. I'm actually going to free everything from memory, dump all of my execution plans, so I got absolutely nothing in cache. Going to turn on my set statistics and my time here. And then I got 2 tables here. One that is partitioned and the second one here that is not partitioned. Everything is the same rows, same data. Only difference is one partitioned, one is not. So, very first thing we're going to notice here is we have our clustered index scan. We're scanning across both here. Only 1%. So if you know very little about execution plans, normally, but not every time, a good starting point here is looking at the cost of 2 queries running together, 99 versus 1. We're also going to see here now we're needing to go parallel. We're up before where we don't have to. So let's go ahead and take a look at some of the things we talked about. So for example, this is the optimizer saying, and I'll switch to green for good, this table is partitioned and only one partition was needed. So that's kind of our best case scenario. Go over to the properties here. Same thing up again. This is a little misleading to me and I think people when they get started. It really means the partition or partitions that are accessed. But here, one partition and partition number 7 was needed. Where over here, you don't see partitioned in here because it wasn't able to use partitioning. So that stuff then is not shown. So if we go now and we look at our I/O here, even though we got a pretty small demo example, this is our good scenario where we got 230 reads. We only scan one partition here versus the whole table scan here. So here we're going parallel and we have over 30,000 reads here that have pages that have to be read. So that's kind of our best case scenario. Now we're going to look at seeking here. And in fact, we're going to look at our worst case scenario with table partitioning for performance. And that will actually be seeking across a table where we're not using our partition column as a filter. So that's going to force us to have to go touch every single partition. All right, so we're going to go ahead and run this here. So we have our two indexes on our two tables. Once again, to get our starting point here, free stuff out, put our statistics I/O on and time on, and then same thing here. So I added that new index for customer ID. And even though it's aligned there, if we don't have a filter based on our partition column, so once again, order date is our partition column, the optimizer is not going to know how to eliminate partitions because there's no way for it to say we don't need these order dates. In fact, we're going to need to look at them all, which makes logical sense here because we're not filtering by order date at all. So I'm going to go ahead and run this here. Here, we're going to see, so this is an interesting thing. While you don't always want to implement every single index here, because we already just implemented the index that we're using here, filtering off of the customer ID. In the properties here, it's telling us to create an exact duplicate index. So this is I know it's a side topic with performance here, but you don't always want to blindly implement these because we already implemented that even, as you can see from right up here. But the point here now is when we look and hover over our tooltip here, we didn't filter on order date. So because of that, I'm going to switch our color to red because this is our worst case scenario. We're not able to skip any partitions. So yes, it's the table is partitioned, but we have to go to every single partition, which is our worst case scenario of performance with partitioning here. Or yes, performancing with partitioning. So because of that, if we look at our I/O here, this is still a small sample, so we have 26 pages here. So the exact number isn't going to be that big, but if you think big term of terabytes and terabytes of data, you're going to see a huge difference in the amount of reads going across here. So the other thing I want to point out here is the scan count. We have 8 partitions. We have to scan across every single one of them. That's why we see a scan count of 8 there. Instead of having just a table without partitioning, we would just scan once across everything. So here's going to be that second case. And we're doing our index seek. And when we look at our I/O here, this is going to be 7. So once again, this ends up actually being a little bit better because our worst case is we have to do a little extra work to go over every single partition. So now that we have that, we're going to do the exact same thing here, except we're going to filter now. We're going to add our order date in here. So now we are going to be able to skip partitions. So we run that there against our partition table. Our hint that you saw before magically went away. So an interesting thing here, we run the query against one partition, we don't get the index recommendation, but when we ran it in that example across, where it had to go across the whole table, every partition, it came up. That's a nice thing to go over with you there. And once again here, instead of our scan every partition, we know we only need one. We're only going to hit that one. And we're still going to use our index that we created here based off of customer ID. So once again here, this is where you can see all that in there on the predicate. And now we're going to see a lot different. So now we went from 27 reads here to 2. And we only had to scan once because we only did one single partition. So next thing here, we're going to do the same thing now with our table that's unpartitioned here. And we're going to see, we're going to do our index seek. We're going to seek across the whole table because we have no partitioning here, and it's a few more. So the key thing to think here, if performance is your driver, you really need to know how your data is going to be used. And you need to find that columns that's there for as many queries as possible that you're using, because your whole goal is going to be to kind of improve performance by skipping partitions that aren't needed for your queries. So that's kind of the good, bad behind partitioning there for performance. So how do we improve archiving and purging? So to do this, here's a real-world example of a scenario where we're using this for a logging feature that just got enabled. Now there was a development process that basically would loop through records, purge them out based off of size, and after we added a new functionality, and this code was used a lot more and a lot more data was pumped through, this process took over 3 hours. Once we switched this over to a table partitioning with our sliding window, this went from hours to a single minute. And the real minute here was actually building out the staging table, which I'm going to show you a great tool that will help you with that. So the nice thing here is the quickest way to move billions of rows is to do what's known as a metadata swap. And this is where you would alter your table and you would basically tell which partition would be swapped with a table. So the partition has to be empty there for you to do this. But this does what's known as a metadata swap. So as long as both that partition and this table are in the same file group, the data never physically has to be moved, so it doesn't happen. Only the metadata internally to SQL Server will get changed. So like the pointers that say, hey, this is where the pages are for this staging table, get shifted over to the partition. So that way, logically, data is never moved, only the metadata gets moved. So as long as you get the schema lock that's required, this will happen instantly, regardless of how much data is in there, because the data never moves. So in order to do your archiving here, you would use split and merge functions, and you'll want to do this with empty partitions. If you remember in the beginning when I showed you the data rows that were inside of our table after we partitioned it, the very first and last partitions were empty. And that's because it's easy to move or split or merge empty partitions. If you actually have data in them, then the data has to physically move from one file group to another. So quickly here we're going to show you exactly how merge works. So merge is basically taking two partitions and making them one. And so if we were going to do it with having right as our range, and we merge here, we're going to see that everything that's in partition 1 will stay there, and partition 2 will get merged into it. So if we were going to do a merge with those two, we'd want to have no data here in our file group 2. So when you have two partitions back-to-back, file group 1 or partition 1 and partition 2 empty, there's no data to actually move, so merging them together will be instantly because there's no data that has to move from one file group to another. So keep in mind here, we're going to see the same thing here for doing a merge here with range left. So same kind of concept. Where this gets different is splitting. So splitting is the process of adding new partitions in. So logically, one would think, hey, if I only have data up to 300 and I want to split on a range value that's higher than data I have, we would just create a brand new partition and throw the data there. And that's what we're seeing, exactly what happens here. So our 350 gets thrown into our our partition 4 here. And we're using next use just on this sliding window to wrap around the file groups here. If you wanted to, you can have a brand new file group attached to different disks. But where this gets different is if you do a split on ranged left. So up top I'm showing you the beginning, and once again, you know, if we have data from 300 up to 349, that data would actually get moved. So range left will put it to the, a split on left, range left, will be put into partition 3 here, and then it'll move and make the last partition 3 now become partition 4. So this is a scenario where people will think that no data will be moved, like with range right, but on range left, it actually will physically move the data that's there. So to drive it home, here's kind of how a basic sliding window would work, where we're going to do archiving and purging. And keep in mind that there could be sessions alone on sliding windows, and those are also going to be unique based on your needs. This is just kind of an example to kind of show you the flow of how one could work, where you want to minimize and have no data movement. So by doing range right, remember our starting partition 1 is empty. We're going to do that metadata swap here in a second, but we've created a staging table that's identical. Has exact same structure, same indexes, same everything, same file group. We're going to do our metadata swap here so that that partition 2 data is going to go into our staging table. But keep in mind, this is a metadata swap, so only the metadata is changed and not a single physical data page gets moved. When we do that swap, now partition 2, if you ran a query against it, will look empty, but our staging table will have all the data. So once again, just to repeat, the physical data is not being moved. So if you're monitoring your transactional log and its usage, you would see no movement here because only the metadata is moving, not the physical data itself. And that's because we are doing a swap between a partition and a table that's in the same file group. So now that we have those two empty partitions next to each other, we can merge them together. And because there's no rows, no data in partition 1, and no data in partition 2, we're basically going to move no data because there's no data to move. That's kind of our secret in this sliding window. If you had data, it would be the same as having a implicit transaction. So you would say begin transaction, insert data from partition 2 into partition 1, and then delete it, and then commit the transaction. So that could be one way a lot of people could blow out their log file, and you want to be careful with that. Make sure you test and fully understand this process in non-production before you use it in production. But here we have no data to move, so no data will get moved because both partitions are empty. All our data from partition 2 is still in that staging table, so we didn't lose it. We can query that staging table and the data will still be there. But we merged them, so we went from 5 partitions to 4. We still have our data from the old partition 2 in our staging table. The next thing what we're going to do here in this example is we're just going to do wraparound file groups. So instead of adding a new file group every single time, we're going to reuse that file group 2 that was used for partition 2. Oh, and there's a mistake on this PowerPoint. The data is still in the staging table there. But from there, we can swap our data back in, and because we split on a value that's higher than what we have there, that's going to be an empty file group. So now we have our partition 5 is back in. We're using file group 2 because we're just rolling around the file groups here. So whichever one is in partition 2, the next time we run this, which would be file group 3, it'll roll around and it'll be for partition 5 there. So here's the basic steps, and I know we took a little long to get configuring, so hopefully I can spend another 10 minutes here. And I'll go over a quick demo of showing you exactly how this works with T-SQL, and then if we have any other questions, Rob, you can run those through me as well. But here's the basic process here that we're going to go ahead and I build a metadata table that keeps a record of everything we do through our sliding window. I'm going to insert that data before we make any changes into that table I'm creating. Then we're going to create our staging table, which is going to be identical. And the reason why I have the sliding window create this is because I've worked in environments where things get implemented outside of change control. And if we had our staging table be there, there's a good chance someone may add an index in on the production table, but it's not on the staging table, and it'll cause this to blow up. So I'm actually going to use a tool that's going to generate our whole staging table for us, making sure it has the right objects and it's on the right file group, so that way we're not making mistakes. So we'll go through that. We'll swap the data out, doing the metadata swap as we merge, and then we'll create our new partition as well. And so with that, I'm going to hop over to that demo here. We'll go all the way back up here. And so as I mentioned, the very first step here, this is a table I'm creating. It's just for me or whoever's going to maintain and own the sliding window process. And this is basically going to run that real big query that we ran before to see everything about the partitions. So the who, what, when, where, why about the partitioning. And then I'm just going to go ahead and take a look at it here. So we're going to go ahead and do that. Here we can see that our table is partitioned. We are using range right. The schema is demo 3 schema. Partition number 2, that's what we're going to pop out. I know exactly how many rows are in there before we do our swap, what file group was used, what the boundary value is. So if I had to, for whatever reason, bring it back, I had all that data that I can use to do that. And then these are just things for me or whoever would manage this process once it gets automated to know when it started, when it ended, and if it was finished. So the very next thing we're going to do is we're going to use an open source tool out on CodePlex called Manage Partition. And this is an executable that basically would run, that has a lot of parameters that would go through and create our staging table for us. So the reason why I do this again is because occasionally people skip change control, and if your staging table isn't identical and isn't using the same file group as the partition you want to switch, that process will fail. So doing this just through PowerShell, I would run the command here and specify that I want to create everything. This is the database I'm using. This is the server. Here's our schema and table, and then the name of the staging table that we're going to create, which partition, and the reason why we specify that is so the tool will use the right file group for you so you don't have to worry. And then we're going to bring over all the indexes and everything else over there. And then for demo purposes here, you can tell this just to run and create it, but here it just would output and show us where that script file would go. Due to time here today, I'm just going to go ahead and run this. But the big difference here you'll see is this is just creating it, and it's going to have it on our file groups for us. So file group 2 is an example. So let me go ahead and run that so we have our staging table. Oh, unselect, run everything. So, and then from here, we can actually start with that metadata swap. So this is what's going to swap out our partition. So I have this stored procedure, which basically was the code I just ran before that shows us everything about partitioning in there. In 2016, if you wanted, you could just truncate the table. And then I'm going to do the select count so you can see the data is in the staging table. And then we'll look and see that what the partitions look like after the process. So here we go. We could saw it was instantly. And this would be instantly regardless amount of the data because the data is not physically moving. So here's our before, where we can see our 7,972 rows get moved. This is the staging table. Remember the select count from staging. And then here's our after step here. So here we have 2 empty partitions right next to each other. When I merge those 2 together, there's no data to actually move. So that's how we have no data movement there. So here, all I'm going to do now is just merge those two together. So let me grab my before here. And then I'm going to merge it, and basically we're going to see us go from 8 to 7. So we're back there. We went from 8 partitions here. Now we got 7. And our 2 empty, now we're going to see that we have data there from file group 3. It's going to push up, and that's now going to be that's going to be partition 2. So everything there. So the next thing I'm going to do, because I'm rotating around the file groups, I'm just going to mark that next. So when we add our next partition, it's going to use that file group 2 that we just emptied there. So the next thing here is I'm going to split. So I'm going to create that new partition using a value that's greater than what we currently have. So like in this case, adding 6 months. And then let me grab that. So there you can see we added our new one there. It added 6 months to the last one we had there. It's using file group 2 because we're rotating around in this sliding window example. And then the last one here is just update metadata for me or anyone else who would be troubleshooting this later on. So we can see started. And then your last part here, this is where you would do whatever you wanted with that data in the staging table. So we still have it. If you wanted to move this to a data warehouse, another reporting box, the data is still there. It's just not going to impact the business apps that are using that table because the data is now in the staging table. In this case, we could just drop it because our process is going to recreate that table. And that is the sliding window. I mean, it's one of many examples of a sliding window there. So with that, here is my contact info. There's the link to where you can access everything we went over, from the backup to get you started, to the source code, to the PowerPoint, to the links to videos of this. And then at this time, if we have questions, Rob, I would be happy to spend a couple minutes going over those as well.
Sure. Let me take a look here. Here's a question. Guidelines on how to consider partitions and why. Do you have any guidelines you recommend to start using partitions and why?
Well, yeah, so the reason on why I'd want to use partitioning is if these are the 3 key things that I started the presentation off. If your maintenance window, if you're not able to maintain your SLA for you doing your maintenance, that could be one reason. If you need to have a quick archiving and purging process, that's another one for big data. And then your third one there could be performance, trying to eliminate partitions. If you have cases where your big tables are mostly all used by a column that's filtered. So
Okay.
That's kind of the starting 5,000 foot level way to kind of look at it. I'd be happy to talk to an individual in more detail if they had other questions or things that they were wanting to know if their scenario was good or bad for partitioning.
Okay. Here's one. What is the impact on insert operations when partitioning is used?
The insert impact. So you're inserting, really, I mean, it's the same thing that you would end up seeing where inserting will go into the partitions that are needed on there based on where you're inserting into. So depending on how you set up your partitioning, and once again, this is more of a bigger question, depending on how you have the files laid out, you can end up making this be even better by having faster disks as persistent for your log. But once again, that's an operation that just flows through that the optimizer will take care of for you.
Okay. I tell you what, we're kind of running a little tight on time. I think we're really getting over. And there's a few more questions. If you don't mind, I'm going to bundle all the questions together and kind of put a star on the ones we didn't hit and send it to you, John, and maybe we could respond back or get back to some of these questions offline.
Yeah, definitely. If there's an email address, I can definitely reach back to those individuals and answer their questions.
Okay, that's perfect. Well, thanks for coming on today, John.
Yep, thanks for having me.
And, you know, we'll do more in the future with joint meetings and maybe some more meetings in the later in the year. So
Awesome.
thank you again, and thanks for everyone coming to the webinar today, and look forward to the next one. Bye.